Hey everybody, welcome back to another SAT video. This is from the 2024 official SAT Test Bundle 6 Math Module 2. A rectangle has an area of 155 square inches and the length of the rectangle is 4 inches less than 7 times the width of the rectangle. What is the width of the rectangle in inches? So this might seem like a simple problem, but I guarantee you it is not. And if you are familiar with factoring and if you've done a little bit of algebra, or I think maybe even algebra 1 or pre-algebra, I forgot how they rank it now, but regardless, you will need to do a lot of factoring for this equation. So let's get to it. First, I like to start off by just writing down what we know. We know the area is 155 inches squared and can be represented by the equation length times width, right? They're also telling us that the length is equal to 4 inches less than 7 times the width. So that means 7 times the width minus 4. So if we combine all this information into one, we basically get our area is equal to W times L, and L is simply 7W minus 4, right? So at W times 7W minus 4, not so bad, right? And that is equal to 155 inches squared. We'll just forget about the units for now. So now we need to basically solve for W. And if we distribute this W in this term, right, so we just basically will get a W squared term, right? W times 7W will be 7W squared minus 4W is equal to 155, right? Now notice we have a W squared, right? And this means this equation is a quadratic equation, meaning it will have two solutions. And in order to figure out a quadratic equation, we need to set one side of the equation to 0 and gather all of our variable terms on the other side, which we kind of already did. So let's first start by setting this right side to 0, 155, and then we minus 155 on this side. So then we get 7W squared minus 4W minus 155 is equal to 0. Now, you might be wondering, why do we need to do this for quadratic equations? Well, recall that quadratic equations, when graphed on the xy plane, these equations are parabolas, right? And the solution to these equations usually means the points of the equation that touch the x-axis, right? And the x-axis is at y equals 0, which is why we usually put one side of the equation equal to 0, right? And notice that it also will have two solutions, right? It will touch the x-axis at two solutions. So that is why we always will set quadratic equations equal to 0 before solving, because the solutions of a quadratic equation mean nothing more than the points at which the parabola representing the equation touches the x-axis, right? And the x-axis will always be at y equals 0. So hopefully that makes sense and gives you a little bit more insight as to why we are doing the stuff we do. Anyways, now that we have our quadratic equation written in a standardized form, we need to factor it and solve for W, right? So the way we can factor this equation, right, usually we would try and break it up into some sort of form like this, where we have two binomial terms, right, meaning two terms with an x and one, like an x would go here, x term would go here, and then we'd have some constants. So that's how we are going to factor it. However, it's not super clear what the common numbers or factors are between these three. And if you ever find yourself in a situation where you need to factor a quadratic equation and you have an a term that is not equal to 1, meaning a meaning like this coefficient, right, of the first term. So let me just explain that. Standard form for quadratic equations is ax squared plus bx plus c, where a, b, and c are constants, right? So if we have a non-1a term, we need to do the following to factor it. we basically multiply this term by the c term. Okay, now just follow along with me. So we first multiply those two terms together and we will get a number, right? So minus 155 times 7 will give us 5 by, let's put a 3 there. 5 times 35 plus 3 is going to be 38. And then 7 times 1 is 7 plus 3 is going to be 10, right? So why did we do this, right? Why did we multiply these two terms together? Well, the reason we are doing that is to figure out how we can split up this middle term into two more terms, right? Because if we say we want to write this equation, right? If we want to write a quadratic equation in the form where it is in two parentheses, right? Some ax plus a number, say y, and then another bx plus like a number c. We need to have four terms in this equation in order to do so. And the way we figure out those four terms is by multiplying the a coefficient by the c coefficient and then figuring out what two multiples of that product will equal when added together the middle term, right? So I'll say that again. We need to basically multiply a times c, right? A times c, get their product, and then figure out the two numbers when multiplied together that equal that product, add up to the b term, right? And that will help us factor. So let's try and do that right now. So in order to find the multiples of 10, negative 1085, I like to just make like a factor tree. You might have done this before in algebra, where you basically just kind of break up the number into its greatest common factors. So since this ends with the 5, we know that this would have to have 5 times something, right? So 5 goes into 10 two times, then 5 goes into 8 one time, right? And then 8 minus 5 will give us 3, so we have like a 15 left over. So we would have like, well, let me just show you what I'm doing, right? I'm basically just doing 1085 long division by 5. You can also do this in your calculators, perfectly fine, right? I'm not really going to worry about the negative for right now, but yeah, like I was saying, 5 goes into 10 two times, that becomes 0. Then we bring the 8 down, it goes into 1 time, that becomes 5. And then that gives us 3. Bring the 5 down, and then 5 goes into 35 7 times, right? So we know that is going to be 217. Let me just clean up my workspace a little bit. Okay. So again, we just basically want to find the greatest common factors, and that will make it a little bit easier to figure out which two numbers, when added up together, will equal minus 4, and when multiplied together give us 1085, right? So 5 times 217 gives us 1085. Let's try and break down 217 into some more numbers, right? So just by looking at this 217, let's try dividing it by 7. The reason why I'm saying let's divide it by 7, because I know 21, like 7 times 3 is 21. So maybe that will work. So let's try it out. 7 goes into 21 3 times. 21, subtract, that gives us 0. And then we drop the 7 down. And then 7 goes into 7 one time. So there we go. Now we know 217 can be further broken up into 7 times 31, right? And we can't really break up 31 into any more numbers because 31 is a prime number, so it doesn't have any factors. So now we know 1085, right? Like if we just write 1085, that is equal to basically 5 times 7 times 31, right? Oh, did not write that. 5 times 7 times 31. But notice that 5 times 7 we can rewrite as 35 times 31, right? So we have actually two numbers, like, and remember, we want to find two numbers when multiplied together that equal 1085 and when added together equal minus 4, right? So we want to basically figure out, okay, would minus 31 times 35, that would equal negative 1085, right? And then also 35 times minus, the other way around, minus 35 times 31 will also equal 1085, but which one of these pairs when added together equals minus 4, right? So of the two, this one would equal minus 4. So if we were to add these together, right, 35 plus minus 35 plus 31, that would equal minus 4, and that is our middle term. That's our b term. So we know that we can split this b term into minus 35 and plus 31 because these two numbers, when multiplied together, equal negative 1085, and when we add them together, they equal minus 4, right? So now we can continue factoring this equation. So let's add in our extra terms that we were able to figure out. So 7w squared minus 35w, right? Minus 35w plus 31w. So remember, we want these two, we add up to equal minus 4, and they do. Minus 155 equals 0. Okay, now let's try and factor these out even further. So when you have, what I mean by factor this out even further, because recall, we want to get our equation in this form when we have like a w here and some other term, so like plus or minus some other term, and then the same thing like over here as we would see in like the standard form of like a graph of a parabola, right? So that's kind of what we want. And when we need to factor into that form, we might have to switch around the middle values over here a little bit. So let's just see if we can do it right now. So let's see, are there any common factors between these two? Well, yeah, there's a common factor between these two. Like 7 goes into that. We could basically have a common factor in these two of a 7w term, right? So we can have 7w, and then that would be times w minus 5, right? Because 7w times w would give us 7w squared. 7w times minus 5 will give us minus 35. But what about these ones? Is there a common factor between 31 and minus 155? Doesn't really work, right? Because 31 is a prime number. So I'm going to actually Control Z all that, and let's try rewriting it with the middle terms switched. So let's say 31w minus 35w minus 155 equals 0. So can we factor these two terms now? Well, we still can, right? Because there's a w common to both of them, so we could factor out a w. W times 7w will give us 7w squared, and then w times 31 would give us just 31w. And what about on this side? On this side, notice how both of these terms are divisible by 5, right? So we could factor out a negative 5, right? So because they also have two negatives, right? So we could say this would be minus 5, and then 5 times 7 is 35, and there's a w, so we could say that would be our 7w term. Negative 5 times 7w is negative 35w, and then minus 5 goes into minus 155. I would say, I think 31 times, right? Let's see, does that make sense? 31 times 5, we get the 5 and then 5. Yep, that makes sense. So then we get a 31 on our second term for the binomial, and that is equal to 0. So we are almost done. Now look, we can factor even one more time. We have a common term, right? A 7w plus 31 here, 7w plus 31 over here. So that means we could factor that out entirely. So then we get 7w plus 31 is times w minus 5, and that is equal to 0. If you're having a hard time understanding how that works, just imagine I did it this way instead, right? Imagine if 7w plus 31 was equal to a, and we rewrote our equation as w times a minus 5 times a is equal to 0, then we would be able to factor out the a, right? We would be able to write it as a times the quantity w minus 5, which is exactly what we did over here, right? Just use the same property for factoring. So we are very close now, right? Is all equal to 0, but remember, this parabola, this equation is a parabola, and it has two solutions, right? It intersects the x-axis at 2 points. So what we got to do now is basically set w minus 5 is equal to 0, and then 7w plus 31 equal to 0, and now we solve for w. So this one is easy, just plus 5 on both sides, and then we get w is equal to 5. If we do solve this one, we have to first minus the 31 on both sides. We get 7w is equal to 31, but it is minus 31, right? Because we subtracted both sides, and then we divide both sides by 7, and we are left with w is equal to minus 31 over 7. So we have two values for w. Now we need to choose which one makes sense given the context of our equation or our problem, right? So they're asking, what is the width of the rectangle in inches, right? So we have two answers, right? How do we know which answer makes sense? Well, would it make sense if you had a negative length, a negative width? Doesn't really make sense, right? I'm not even sure what that would mean. So we know that since this one is negative, we could probably just disregard it and know that, okay, since this is the only positive answer that we have, this is likely going to be the answer, right? Because it makes sense. If you have a width of 5 inches, that actually makes sense. You can't have a negative 5 width. At least in the context of the SAT, it doesn't make sense. So that means our width is going to be 5. So there you have it. This question is actually pretty hard. So don't be discouraged if a lot of this doesn't make sense or if this is new to you. By this point, you probably would have needed to take at least Algebra 1 to have understood these concepts. And even these are pretty advanced Algebra 1 concepts. So don't feel discouraged. It's a hard question, but hopefully you now have the tools to identify such a question and solve for it. So I'm just going to summarize again. The first thing we did was write out all the information that we knew, right? We figured out that the length could be written in terms of W, and then we plugged it into an equation and noticed that it became a quadratic equation, right? Because how did I know it was a quadratic equation? Because we had terms we had a variable term that was squared, and then when we rewrite, then we had to basically understand that at that point this equation was a quadratic equation, right? And whenever you try to solve a quadratic equation, we have to bring all the terms to the left side and then set it equal to 0, which we did right here. Once we did that, we had to basically understand that whenever you want to solve a quadratic equation, you need to split the middle term into two terms. And the way to do that is by getting the a coefficient and the c coefficient, or in other words, the coefficient attached to the w squared and the constant that has no x or w associated with it. Multiply those two together as we did right here. So we multiplied those two together. They gave us that number, negative 1085. Once we figured that out, we had to find two numbers that, when multiplied together, equal negative 1085 and also add up to the middle term, right? So to figure out the two numbers, we made a factor tree of negative 1085. Also, you could use your calculator to do so, but we made a factor tree to do so. Figured out that our pair that equals negative 4 when added together and multiplies into negative 1085 was negative 35 times 31. Then we added those two numbers into our main equation. We had to swap the position of these two numbers so that we could continue factoring. Once we did that, we factored out the equations. So we factored out these two terms, and then we factored basically these terms and these two terms. Once we did that, we were able to find another common factor between the whole equation, and then we're able to rewrite it in the terms that we could use to then solve for W. once we did that, we had to solve for W for both cases, right? We have one case where for this solution and then for this solution. So we solved for W for both solutions. And then we basically had to figure out, okay, of these two solutions, which makes sense when you have a negative length that doesn't make sense. So we knew that 5 was going to be our answer. So there you have it. That is the answer for this question. Let me know if anything was unclear or if I can do a better job at conveying the information or any other improvements. As always, feel free to check out Khan Academy. They have a lot of great resources, especially for factoring in these sorts of things. And as always, thank you for watching.